Hi, welcome back, guys. So we are moving on. Hopefully, you guys did pretty well with section one and got it all down. If not, shoot me an email and we'll see what I can do for you and help you guys out in any way possible. But we're gonna move on today to 11.2. Okay, so 11.2. So this is going to be area of sectors of a circle. So this is, before we did a lot with arc length, and we kind of found the length of different parts of a circle, which is like the circumference. This time what we're doing is we're taking like the area of that, all right? So basically we're saying if you look at the shaded region right in here, all right, we're basically saying we don't want to, I think of like painting. We don't want to paint the whole circle. We just want to paint this part. How much paint are we going to need and everything like that. Like questions like that is what we're going to see. But like I said, I kind of think about it like that because we're talking about area for this. So if we're looking to fill in the first section of notes here, so a sector is just a section. It's just a section of a circle, and it's bounded by a central angle. Okay, so back to when we were talking about central angles, because guess what? Those angle measures are coming into play again. And it's intercepted arc. Guys, intercepted arc just means the arc formed by that angle. So basically, the intercepted arc is this arc right here. Okay, that's the intercepted arc. It's the outside part of the circle. So this is where kind of just think of a sector as like, hey, a slice of pizza. All right. So this is just a slice of pizza. So instead of eating the whole circle, we only get that gray slice. All right. So we have a formula for this, and the formula is very similar to the arc length formula. All right, so don't get those two confused. But again, we're using X and we're using R, okay? We're using X and we're using R. So these are our two variables over here that are going to be in our formula. So for the area, we're going to use A for area. A for the sector, it's going to equal X. What is X? X is the degree measure of the arc, okay? X is the degree measure, just like we did when we found arc length. We multiply that by pi r squared. Okay, so that's going to be the top of our fraction. Now, degree measures X, and then pi r squared, that's just the area of a circle. So we're taking the degree measure, multiplying it by the area of that circle, and we're dividing it all by 360. Hopefully that does look similar to the arc length, but remember, this time we're looking for that sector, not the section of the outside part of the circle. We're looking for the sector. We're looking for that slice of pizza, okay? So let's go through some examples here. So find the area of each shaded sector. Excuse me. So we first have to find our degree measure. So if we look down there, that's 51 degrees. Okay. Then we have to find out, it tells us BC, all right, is 16. So is BC a radius or diameter? You should be saying radius, all right? It's a radius. So we can plug this in our formula because we have our radius of 16, all right? So X equals 51, R equals 16. That's the two pieces of information that we need to know to plug in our formula. So we're going to do, because our formula is X times pi r squared divided by 360. That's our formula to find the area. So we're going to plug in our X. So 51 times pi times 16 squared. Okay? Divide that all by 360. Once we do that, we can punch that in our calculator and get a final answer of 113.94. And that's going to be feet squared. 113.94. So that isn't too terribly difficult, hopefully, guys. So if we're looking at number 2,